Hi guys. Today we are going to solve a binary tree question. Sorry, one second. Yeah. So today we're going to solve a binary question in which we are going to merge two binary trees. So what I mean by that is, for example, if I've given this tree, I'm given this tree also. So we have to merge these two binary trees in this form. So we have to also overlap them. That means that this has to be, these two have to be overlapped. Means they have to be summed. For example, and one more thing, if it doesn't have a node, so this tree doesn't have a right node, so this node doesn't have a right child. So what we have to do is we have to take the right child of this node. This should be the resultant answer. So what should be the approach of solving this question? What comes in mind is that we can do a pre-order traversal in this question. So what we can do is we can traverse this tree first. Let's just traverse this tree. In this question, it's not given that we have to return a new tree. We can use this tree and manipulate this tree itself. We can start from any tree. So I'm just starting from the first tree itself. What I'm going to do is I'm going to traverse this tree. So I will go to the left child of this tree, and simultaneously I will go to the right child of the left child of this tree also. Now what I will do is I'll go to the left child, okay, left child of this tree. It doesn't have a left child, which is not a problem. So it's not going to be it will not go there, right? So it will not go there. So what we will also keep one thing in mind. So we have gone left, we have gone to the right left child of this tree. So when we come back, we will go to the right child, but this doesn't have a right child, but this does. So what we will do is we will add that left this right child into this 4, which is being done like that. Then we'll go back, and then we'll come to this position, the right child of this. So we'll go to the left child, as this both don't have a left child, so not a problem. We'll go to the right child, but this doesn't have a right child, but this does. So we can do one thing is that we can add this right child like this. Seems a bit confusing, but we can easily do this. So in a pre-order traversal, you know that first of all, what you do is first let me just recap pre-order traversal, pre-order traverse. So what you can do is I will just say PO, you have root. So if let me just write the code. So this is the code for the pre-order traversal, as you can see. So what we can do with this, we are just going to modify this code itself because this is just a simple traversal question in which just some things have been twisted. So we will also deal with those twists. So first of all, we have to change. What we are going to do is we are going to use root 1 and root 2, both the roots of the trees. Okay. And we have to do some modifications here. That is one important thing here. We have to do the modification on. So for example, this pre-order traversal, instead of printing, what we can do is root ones root ones dot val can be updated with, sorry, val can be updated with root 2's value. Okay. What we can do is root 1 dot left here itself and root 2 dot left itself. We can do both traversals. Right? Yes. So now, and one more thing we have to think of is that the return type of this node will obviously be a node, obviously, because, for example, this part, this tree didn't have a right part, right? Exactly. This tree didn't have a right part. This was the initial tree we had, right? Second, yes, this is the tree we had initially. So this tree didn't have a right part, but this had. So what we had to do is we had to add a right part for this tree. How can we do that? So let's go there. Then what we can do is we can update these parts. Okay. So what we can do is root ones dot left is equal to this. Root twos dot root twos dot right equal to this. And we can return root one itself. I know this code is a bit tricky, but we'll get to it. So now let's find the one thing that we are looking for. For example, if t1 is equal to null, for example, I'm traversing to the right side. It is null. What can I do? I can return this thing. Yes, I can return the right part of it. So where is it? It is return root 2 we can return. Exactly. And if t2 is equal to null, then that is also simple, quite simple. For example, this was null, right? So if this is null, we could have simply returned 5 to it, the node itself. So we can return 2, return root 1. Yep. And this is the code that we wanted. So let's do a dry run on this question itself so we can understand it much better. I'll just squeeze in this code. Just 1 second. Yeah, once. So let's start with the traversal. So what we are going to call is PO, right? I'll just call it from this side. PO. You understand the code. Don't worry. PO. We're going to start with root 1. Let's say it's 1. We're going to start with 2, right? So now what we are going to do is we are going to, if t1 is equal to null, which is not null, and t2 is null, which is not null. So what we have to do is first we have to increment the value. Dot root dot val is plus 1 is equal to root 2 dot val. So what we can do is, for example, it's not a new tree. I'm just updating this value. So what I'm trying to do is now what I've added is this one was earlier, so this is now 3. This is the result. After doing this is the periodic part. We are going to make root 1's left, which is its left, equal to this. How are we going to find that? We are going to find that. So now root 1's left is equal to root 1's left and root 2's left. So what we are going to make a call is left and left of both the parts. So we are going to make a call for 3 and 1. Yes. In order to get 3 and 1, we are again going to make a left call. Right? In this left call, we are going to make a call. P 5 will be there, but there will be a null here. Right? Yeah, exactly. That will also be root 1's left. Means this one's left. So if t2 is null, then what we are going to return simply 5. So means 5 is going to return this. The tree 5. Exactly. Now we are going to make a right call. Right call. So null will be there, right? And 4 will be there. This part. So we'll check again. Sorry. If t1 is equal to null, which is actually true. T1 is null. So what we have to return? We have to return root 2. We return 4. So once we get these both, the root 1's left is this, right? And this is, sorry, this is not root 2. This is going to be root 1 itself. Sorry. Root 1's right. Yeah. So now what we get is, in this position, we get is this. We have 3 as a node, and its left is 5, and its right is 4. This is going to be returned. This thing is going to be returned to this. So once we have made a call, the part, we're going to make the right part. This node. So once we go to the right, we are at PO, and we are at 2. Sorry, we are at spin node here, and we are at 3. So this again we will make a left call PO, it doesn't have, well, now one more thing. This is null and this is null, but the order will be followed. So if t1 is equal to null, so t1 is null. So return null. Return null of what? Of root 2. That is also null. Yes. So right now, what we have is we are working on this. 2's left, what we have done is 2's left is null, which is fine. Now we will work on 2's right. Let's go to the right part. In the right part, we have, right now we don't have a right part, but we have 2's right and then 3's right, which is 7. We will check if t1 is equal to null. So this is true. So what we have to return? Return 7, right? Obviously root 2 means we have to return this value. What it will be returned and this will come like that. Exactly. So once this part is complete, this will be returned to this. Both of these will be returned to what? Both of these will be returned to 1. So now once right left part will be this, and once right part will be 2. And I forgot one thing. I forgot to add them. That's my mistake. They will be added. Just I just missed that part. My bad. So this will be the solution.